redox potential. And we call them ignoble metals. Or non-precious. Or even base metals. The standard hydrogen system this is hydrogen plus water. Well, it's in water. It forms H3O plus 2 electrons. So we have 2 of them, and we have 2 of them. And here the redox potential, we say that is 0 volt. That is the standard. Now written in a more fully formed, not only focusing on hydrogen and H+, we have it in water. Noble metals are located below. The standard hydrogen system, and they have a positive redox potential. Let's have a look to, we are looking to a system. We have, let's say we have elementary zinc, and we put it in an acid. What are you expecting? Very good. Because zinc is oxidized very easily. It has a negative standard potential. It's above the hydrogen system. So zinc will be oxidized, and the acid, so a lot of protons, here it will be reduced to form hydrogen gas. And we will have an example in the lab next semester where we use not zinc, where we use aluminium. Aluminium, what do you know about aluminium? 3+, yeah, you can see maybe. We have, so do you think aluminium is noble? Is it a noble metal or an ignoble metal? It's ignoble, yeah, it's not very noble. So it is above the hydrogen system. So aluminium must be above, anywhere above the hydrogen system. So in here. So when we have aluminium in an acid, it will create hydrogen gas and aluminium will be dissolved. But what we can observe is, oh, it does not react very easily. It takes quite a long time. Do you know why? Very good. Aluminium has a protective oxygen coating. So it is protected by a layer of aluminium oxide. When you have aluminium in the air, immediately Al, what's the formula of the aluminium? 2O3, yeah, because here 0, here 0, here +3, we saw it before, plus the -2. So an aluminium oxide is built immediately. So we have here an aluminium, that's pure aluminium, and it is coated by aluminium oxide, Al2O3, which forms a very dense layer, an airtight layer on the surface of the aluminium, and aluminium oxide is very stable. It protects the aluminium below from further oxidation. That's why we are using aluminium for a lot of applications. Maybe you pack your fruit in a foil of aluminium, or you have some installations done by aluminium. We only can do that because it's not corrosing due to the fact that it is stable. Why we have that layer of aluminium oxide, which is airtight and covering the aluminium from further oxidation. So it is not noble, but it's very stable due to that fact. So aluminium is not noble, is ignoble. So it has a negative redox potential. But it is stable due to the dense layer of aluminium oxide on the surface, which is built immediately. In contact with air. So if you turn off a piece of aluminium foil, immediately the surface, the new surface is coated again by aluminium oxide, and then it stops. No further oxidation. For iron, that doesn't happen. You have the iron oxide, and if you ever have seen, you touch it, you get brown fingers. The iron oxide is removed very easily, and the layer below starts to be oxidized immediately. And after a while, the iron is totally oxidized. For the aluminium, that doesn't happen. So 1 minute, I need more, 1 or 2 minutes, please. Then we are done for today. When we have, for example, the zinc, and we add the H3O plus in an acidic environment, the zinc is oxidized, and we will have the production of hydrogen gas and water. And the hydrogen gas, we can see the bubbles. For the aluminium, we will expect that as well, but it is very stable. So for aluminium, it is quite stable. First, you have to destroy the layer of aluminum oxide, and then it's oxidized. Normally, for the aluminium, we would expect aluminium is not noble, so it is oxidized to form aluminium 3 plus 3 electrons. But that happens only on the surface and then stops because the below aluminium is covered. Okay. So thank you very much for your attention today. We will go on with that topic, talking about electrolysis next week. And this is very important even for renewable energies later on. So hope to see you next Wednesday. I think we are down again in the room where we were normally. Bye-bye.
Hello, sir.
Yes.
Can I have your 2 minutes?
2 minutes, yes.
Sir, I applied for ECTS transfer for my
Please,
chemistry course.
can you wait a minute because it's quite loud in here?
Okay.
And stay in, and then we can talk to each other in 5 minutes.
Okay, sir.
Okay.
Perfect.
So, Syed, are you online?
Yes, sir.
Okay. So,
Uh, Basically, I did my fourth semester from Turkey. In mechanical engineering, there I read chemistry, and here I applied for transfer ECTS in this field. So I didn't hear any response from the university for my credit transfers, and they told me contact your lecturer, professor.
Mhm.
Yeah.
So what is the question?
To transfer my ECTS here because I already passed chemistry in Turkey.
Did you fill out the formula for the credit transfer?
Yes, I filled out.
And well, from which university are you coming?
Austrian Technical University, Ankara.
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 Maybe I got a lot of papers for credit transfer. Most of them I did not accept.
Mhm.
But I'm not aware on your example because I always look to the previous work which is done at the previous university, and if this fits totally or more or less 90% to that what we are doing here,
Mhm.
I can accept. But I'm not remembering your special case. Maybe you can send me the formula once more.
Sir, can you share your email with me?
Yeah, you find me on the web page of the ECRI. You find my email address.
Okay, because sir, my previous university is in Bologna system, so I hope it will help me.
It is what in which system? In Bologna system. Yeah.
Yeah.
If it's in Bologna system, it helps. Yes. Normally it helps because we have a common agreement, and normally the quality should be similar to that what we're doing. But I have to check it. Please send me the formula filled out with all the needed documents. What
Mhm.
is done in the lecture course you did in Ankara, and
Mhm.
what was the grade, and the certificate for it, and then I check.
Okay, sir. I will send you the email today.
Yeah,
So,
normally it has to be done latest in November, and I will have a check if you already handed it over. Maybe I didn't see it.
okay, sir. I will provide you today. I will send you the email, all the things. So then kindly respond me as soon as possible because you know there's exams also in January, after January. So I have to prepare for this if my course is not uh, passed.
Okay, that's it.
Okay, okay, sir. Thank you so much for your time.
Yeah.
Bye. Cheers.
Bye bye.